we do? How can we avoid this skin effect? To avoid this skin effect, we can take 6 conductors, and each conductor is insulated against the other conductor. As the conductor have the same potential actually, then the insulation has to be very, very thin. You just need a very thin insulation. But in case there is a small and very thin insulation, in that case, then you have the influence from one field, magnetic field, on the other magnetic field. We will see. So, Millikan conductor. So, one conductor has this magnetic field strength, and if in case we have a Millikan conductor, then each sector is insulated against the other one. And then each sector has its own magnetic field strength. So if each sector has its own magnetic field strength, so the magnetic field strength of the one conductor will be reduced by the magnetic field strength of the other conductor, of the next conductor. And therefore, you can reduce the residual magnetic field in each conductor. And that's the aim, because the magnetic field is the reason for the skin effect. And so, in case you can reduce the magnetic field by using the magnetic field of the next conductor, in that case you can reduce the residual magnetic field strength. And thus you reduce the skin effect. This is very interesting. Questions to this? So if you have any questions, don't hesitate. So, okay, so the segments are insulated, and each segment has the same H behavior, and the residual H field is reduced, and so the skin effect is reduced. Now the word stranding of the conductor. So when you want to build a conductor that consists of several wires, then how do you produce this conductor? You have first one wire. This wire is pulled in this direction. And then you have small drums with additional wires, copper wires for example. And they are turned in this direction, and the other is maybe turned in this direction, and you pull them together with this head here, and they are pulled together. So, for example, this. So, now I think you can see better, a little bit better when the light is off. So you see, this is the production. This is the production of a conductor. This is the stranding. So it turns. You see, there are big machines. Yeah, they turn and turn, and here they tape the conductor. So with a conductive tape to have smooth surface. What we talk about this a lot. So as well, if you have a lot, if you are already quick, or you have big machines, these are already insulated wires, and they want to form a bigger cable. So you might see that are quite huge machines and they are all turning like you have seen in the movie before. And like this as well. So these are pictures of a factory. So for example, for telecommunication, you need a lot of wires, and you put them all together, so you have a lot of drums with telecommunication wires, and you all put them together to one telecommunication cable, for example. Oil paint insulation, as I said already, we will skip. Yeah, because they are not produced anymore. Maybe there are very few factories that are still producing oil-filled cable in the world. That's actually a problem, because when you work in a company or a distribution company, and there is an oil cable and there is a failure at the oil cable, there's nobody who will repair the oil cable. There's no company that is able to repair anymore an oil cable. So if there is now a failure in an oil cable, then actually you have to replace it by a complete new cable system. This is so now let's go further to synthetic insulation material. If we want to talk about this, then we have to check what plastic material we can use for our cable. In principle, we could use PVC, polyvinyl chloride. Polyvinyl chloride is very cheap, you can use it, it's very good to handle. And you can use polyethylene, that's more expensive than PVC. And then, I will explain later what this is, you can use cross-linked polyethylene. I will explain later. And you can use EPR, ethylene propylene. I'm not sure if it's used in Malaysia, so let's talk about these materials. Some figures of these materials. So we will compare PVC, polyethylene, and XLPE. And for example, the tungsten data, we have talked about the tungsten data. Tungsten data for PVC is 40 times 10 to the power of minus. For polyethylene, it's much smaller. And as well for XLPE. And additionally, the permittivity is 3 to 8 for PVC and 2.3 for polyethylene. You see, the permittivity is smaller than PVC, and the tungsten data is smaller than PVC. And you now remember the equation U squared multiplied omega C tungsten data. So the capacity depends on the permittivity, it's smaller, and as well the tungsten data is smaller. So the dielectric losses, if you use polyethylene as an insulation, is 100 times smaller than at PVC. So we have 100 times smaller losses, dielectric losses, in polyethylene than in PVC. And that's the reason why for high voltage or medium voltage, so 10 up to 10 kV, we use only polyethylene as an insulation. We only use polyethylene. We cannot use PVC as an insulation for higher voltages because of the high dielectric losses inside of the insulation from PVC. Just for the 400 volt, PVC is fine because it's very cheap, not so expensive, let's say. And but for higher voltages, you cannot use PVC, even due to this values. When we check other values, for example, operating temperature, you see PVC and polyethylene, we have both with 70 degrees centigrade. But if we use XLPE, explain what is XLPE. When we use XLPE, we can increase the temperature of the cable conductor up to 90 degrees centigrade. That means that we can transport more electrical power with the same cable system, because we can increase the maximum temperature. As well, the sulfur temperature for XLPE cable we can increase. So now, let's talk a little bit about the different materials, just to get an idea of the different materials. So PVC, as I said, is used only up to 1 kV, not more, because of the high dielectric losses. This is the formula of the PVC, polyvinyl chloride. You see, chloride is at this part, and fluoride in the periodic system is on the very right side. So you see, it is negative when you look on the periodic system. So the chloride is negative. So this is a not symmetric molecule. Yeah, it's not symmetric. What does that mean when it is not symmetric? That means that the charges inside of the molecule are not the same at any place, at every place. So that means PVC is polar. What means PVC is polar? Means polar molecule have an electric dipole moment. Electric dipole moment. What does that mean? It means if I have a molecule, in total is neutral, but inside of the molecule you have a more positive and more negative area. Yes. But for example, we have several of these molecules. What happens in an AC electrical field? In an AC electrical field, then these molecules are moving. They are moving. And when they are moving, they are touching to each other. When they are touching to each other, heat will come. Yeah? When you do like this, it will do that. So heat will come. So heat are losses. So you see, these molecules produce the so-called polarization losses. Very important word, polarization losses. And you see that polarization losses depend on the frequency. Yeah? When you rub very slowly, it's not very hot. When you rub more, it becomes hotter. When you're very hot, you cannot move so when the frequency is very high, then you have smaller losses again. So therefore, it depends on the frequency as well, but as well as 50 Hz you have quite big losses. So this is not good for high voltages, therefore, due to the polarization losses, because the cables, the molecule PVC is a polar material. Okay. So let's talk a little about the behavior of the material PVC. PVC itself is hard and brittle. So therefore, because we want to have a smooth cable, we have to blend it. It is blended with a so-called plasticizer. Plasticizer, and about 20%. And you have usually, you color it, so you put color on it. You use a stabilizer, lead sulfate, for example. You use a filler material, it's calc and kaolin. And you just fill it that it becomes more smoother. And however, these plasticizers are as well polar materials. And these polar materials attach to the polar groups of the PVC. And so these plasticizers are like a little oil, like an oil, and so that smoothens the PVC. The material, the plasticizer is, for example, diethylhexaphthalate. And you see DHP. This is unhealthy. And actually, I advise you, for example, not to buy toys for your children made of PVC. Because your children are taking the toys in the mouth, and then these unhealthy material will go in the mouth of the children. And so please do not buy PVC toys to your children, even not for your dog or your cat or something like that, because this is really unhealthy. Please check when you have toys for your children that they might take in the mouth. Check it even when you have a bottle for drinking for the children, or just a sugar for the small children. Check if these are not made from PVC, because the PVC material has plasticizer and they are unhealthy. Nowadays, more and more, there is a substitute material called mesamol, but as well, I would never give PVC to a child as it were. So really check this. Okay, what are the disadvantages? For example, these pesticides, however, with heat, they go out of the cable. Maybe you change a lamp on an older house, then you see that the insulation is really brittle. The insulation comes down because the lamp heated up the cable, and so there is no pesticide anymore. And so the insulation becomes brittle and falls down. The advantages for PVC, there are advantages. The advantage is it's inexpensive and it's easy processable, it's easy to produce, it's easy sustainable and can be laid in earth direct. There are two processes to produce PVC, but we don't have to talk about this. As you are an engineer, that is you who will decide what material will be used for a project. So you will decide what material will be used. So when you decide for a material, you are the one who has to be in mind, who has to check what will happen in case of fire. Because you always, as an engineer, you are responsible for the security. So therefore, you always have to check what will happen in case of fire. And what happens in case of fire if you use PVC? So what happens? PVC is flame retardant and does not conduct fire. So therefore, very often customers want the outer part of the cable should be PVC. For example, the customer in Singapore, they bought the cable by me, and they always wanted PVC as an outer shielding of the cable. They always wanted to convince them not to use PVC, but they said, no, we want PVC, we want PVC. Okay, they got it. They wanted to convince them that not to use it because in case of fire, PVC produces smoke and toxic gases, and really a lot. So in case of fire, you have smoke and you cannot find the accident. So there was a big accident in Airport Düsseldorf in Germany several years ago, and there was a fire, and all these canals and all these things were made of PVC, and suddenly nobody could find the exit, and several people died. So that was really, really bad thing, and since that time, in Germany, in public buildings, these things in the building should not be made out of PVC because of the smoke and toxic gases. Yeah. So therefore, actually, however, it is flame retardant. So when there is a fire, the fire will not be conducted along the cable. It will stay in the place. But then you get smoke, and the smoke is everywhere, and you will not find it. So it depends, is there a public area, so are there people there? Then I think we should not use PVC. If there are no people, it's fine because it will not conduct the fire. When there comes a firefighter, then they fight with water usually. So, but we have PVC, polyvinyl chloride. What is with the chloride? We have the chloride together with water. The chloride together with water will be hydrochloride acid. Hydrochloride acid, Salzsäure in German, I don't know the English word is hydrochloride acid. So that's really dangerous and that will damage a lot. So the firefighter with the water and the PVC will produce hydrochloride acid, and this hydrochloride acid will damage more than the fire itself. So, but you have to consider. So PVC is not expensive, but it's fine as a material. We have questions. Then we talk about the material polyethylene. There are two sorts of polyethylene that are produced. The one is produced with a catalyzer at room temperature at 20 bar. Then there is a polymerization, and this comes, we say it's a high density polyethylene. That's a mechanically rigid polyethylene. Another one is O2 as a catalyzer at 200 degrees centigrade and 2000 bar as a pressure. And then after the polymerization, we say it's a low density polyethylene. Low density polyethylene. This material for the low density